Ever wondered where gold in your jewelry came from? Or the carbon in your body? Turns out stars are cosmic chefs, cooking up every element in the universe. From hydrogen to uranium, it's all made in stellar kitchens. Let me take you inside a star's kitchen, where the temperature is a casual 15 million degrees Celsius. That's hot enough to smash hydrogen atoms together like a cosmic game of billiards. These atomic collisions create helium, and that's just the appetizer. As stars age, they cook up heavier elements: carbon, oxygen, even iron. It's like a cosmic pressure cooker on steroids. The crazy part? Every gold ring you wear, every calcium atom in your bones, and every breath of oxygen you take, it all came from this stellar cooking show. Stars are basically the Gordon Ramsays of the universe, except instead of yelling at sous chefs, they're creating the building blocks of everything we see. Here's something mind-blowing. Every carbon atom in your body was once inside a star. When massive stars run out of fuel, they explode in spectacular supernovas, spraying these carbon atoms across space like cosmic confetti. These atoms drift through space, eventually clumping together in giant clouds. Over millions of years, they form new solar systems, planets, and eventually, life itself. The carbon in your morning coffee, it's been recycled through countless stars. The atoms in your DNA, they're billions of years old, cooked up in stellar furnaces long before Earth existed. You're literally made of star stuff. How cool is that? Here's where things get spicy. Size really matters in the stellar kitchen. Think of small stars like your home stove. They can cook up some basic dishes like helium and carbon. But massive stars? They're like industrial blast furnaces. These cosmic heavyweights have such intense pressure and heat at their cores that they can forge elements all the way up to iron. A star 20 times bigger than our sun can create more elements in a few million years than our sun will in its entire 10 billion year lifetime. It's like comparing a microwave dinner to a 5-star restaurant. When these massive stars go boom in spectacular supernovas, they create a burst of cooking so intense it makes elements even heavier than iron. That's where we get stuff like gold and uranium. Ready for the most explosive cooking show in the universe? When massive stars run out of fuel, they don't just fizzle out, they go out with a bang. We're talking about supernovas, nature's wildest fireworks display. In just a few seconds, these stellar explosions cook up more elements than the star made in its entire life. The temperature hits a mind-boggling 100 billion degrees. That's way hotter than any kitchen you've ever seen. These cosmic explosions blast newly cooked elements into space at speeds of 70 million miles per hour. It's like a galactic food fight where the ingredients end up everywhere. And I mean everywhere, the gold in your wedding ring. It was probably cooked up in one of these stellar explosions billions of years ago. Okay, forget supernovas for a second. Let's talk about something even more intense: neutron-star collisions. These cosmic crashes are like the universe's ultimate jewelry factory. When two neutron stars smash together, they create conditions so extreme they make supernovas look like sparklers. The crash sprays out a soup of neutrons that rapidly form into heavy elements. And here's the kicker: this is where most of Earth's gold comes from. One neutron-star collision can create enough gold to fill Earth's oceans. Next time you're admiring that gold necklace, remember, those atoms were forged in a cosmic crash that would make any action movie look boring. Let's rewind the cosmic clock all the way back to the beginning. I mean the very beginning. Right after the Big Bang, the universe was like a cosmic soup, hotter than anything we can imagine. In those first 3 minutes, it was basically the universe's first cooking show. The whole place was so hot and dense that simple protons and neutrons started sticking together, creating the universe's first elements: hydrogen and helium. That's it. Just those two. No carbon, no gold, no iron, nothing fancy. It's wild to think that everything we see today started with just these two simple ingredients. The universe was like a chef with only salt and pepper in the pantry, waiting billions of years before stars would come along and add more spices to the mix. Let's crack open one of science's biggest mysteries. How did we figure out stars were making elements? Back in the 1920s, scientists were scratching their heads about something weird. The sun seemed to be mostly hydrogen, but Earth had way more complex stuff. Enter Cecilia Payne, a total rock star astronomer who first suggested stars were hydrogen-powered furnaces. But the real aha moment came from Fred Hoyle in the 1940s. He was trying to solve the puzzle of carbon. There was way too much of it floating around for the Big Bang to explain. Hoyle realized stars must be the missing piece, secretly cooking up elements in their cores. It's like he caught the universe's master chef in action. When other scientists checked his math, everything clicked into place. Let's talk about the universe's weirdest recipe fails. Brown dwarfs are basically stars that never quite made it, like a souffle that refused to rise. These cosmic wannabes are too big to be planets but too small to kickstart the nuclear fusion that makes stars shine. But here's where it gets really strange. There's something even more mysterious out there called dark matter. We can't see it, touch it, or create it in our labs, but we know it's there because galaxies are spinning way faster than they should be. It's like having an invisible ingredient that makes up 85% of the universe's mass. Scientists have been trying to catch this ghostly stuff for decades, but it keeps playing hide and seek with our detectors. Let's get cooking with the most versatile element in the universe, carbon. This little atomic superstar is like the Swiss Army knife of elements. It can form up to 4 stable bonds at once, creating more compounds than all other elements combined. Want to build a protein? Carbon's got your back. Need to store energy in sugar? Carbon's your guy. DNA, cell membranes, even your morning coffee. Carbon makes it all possible. It's so good at making complex molecules that life literally couldn't exist without it. And get this, scientists have looked for silicon-based life, carbon's closest chemical cousin, but nothing beats carbon's molecular magic. It's the ultimate building block, the master chef of life's recipe. Here's a cosmic reality check that'll blow your mind. Stars can't keep cooking forever. Fast forward a few trillion years, and our universe is going to look pretty different. Most stars will have burned through their hydrogen fuel, leaving behind cold, dark remnants. The big cosmic kitchens will shut down one by one. Any new stars forming then will only have leftover ingredients to work with. No fresh element cooking. It's like a restaurant running out of ingredients and having to make do with what's in the freezer. The good news, we've got billions of years before this happens, and our current universe has cooked up enough elements to last us practically forever. Still, it's wild to think about a future where the cosmic ovens finally cool off. Thanks for joining me on this cosmic cooking adventure. You're literally made of stardust. How amazing is that? If you enjoyed this stellar journey, smash that like button, hit subscribe, and share this video with your fellow space foodies.